Hello, my name is Camilo Heras and I am a postdoc at IFT. I will talk today about a work in progress related to the role of torsion in the local and global description of quantum M2-branes and their corresponding double-dimensional reduction. Quantum M2-branes are membranes with discrete supersymmetric spectrum with finite multiplicity. They do not contain the spikes that were previously associated with instabilities of the theory. In our case, we are considering a background which is toroidally compactified and toroidal membranes with a non-vanishing winding on the torus of the target space. The work volume description it is known, and the global description it is given in terms of twisted torus bundles with monodromy. The fiber is a Heisenberg-Neal manifold related to the compact sector of the target space. The base manifold is a torus related to the special directions of the work volume, and the monodromy containing SL2Z is related to the isotopy classes of area-preserving diffeomorphism. Besides the Heisenberg-Neal manifold of the fiber, there are different twisted torus structures contained in the M2-brane bundle description. They are associated with the inequivalent conjugacy classes of SL2Z. These twisted torus imply the existence of torsion cycles on the fiber, which is related to the compactification manifold. Twisted tori in 3 dimensions are not the only solved manifolds that are contained in the M2-brane bundle description. For example, for parabolic monodromies, there is a Kodaira torsion manifold related to order 1 torsion and an extended Heisenberg-Neal manifold of 4 dimensions related to torsion of order greater than 1. For trivial monodromy, we have that there are equivalence classes of bundles that contain only one element. Transformation between inequivalent bundles is given by SL2Z. We have shown in the past that the double-dimensional reduction leads, in this case, to bound states of PQ strings compactified on a circle, while the low energy limit is given by type 2 maximal supergravity in 9 dimensions. For non-trivial monodromies, there are equivalence classes of bundles that contain more than one element. We have proved that the transformation within equivalent bundles reproduce the symmetry group of type 2 big H supergravities in 9 dimensions, and that the transformation between inequivalent bundles is related to the action of U-duality, a subgroup of SL2Z. For parabolic monodromies, the torsion induces a cyclic transformation on the inequivalent classes of bundles. It means that the integers, which will be related to the winding and Kaluza-Klein charges, should be restricted to the integers modulo n, where n is the order of the torsion contribution. These features will be induced on the associated strings obtained via a double-dimensional reduction. As a bottom line, we know the Hamiltonian description of M2-branes with a discrete supersymmetric spectrum, the global description is well defined, the low energy limit for non-trivial monodromies is related to type 2 big H supergravities in 9 dimensions, the role of torsion can be traced in the local and global description on quantum M2-branes, as well as in the strings obtained by a double-dimensional reduction. Thank you very much for your attention.